AC motor, alternating motor. An electric motor is a device that contain convert electrical energy into mechanical energy. An AC convert has two basic electrical parts, a stator and a rotor, as shown in figure 14.12. The stator is the stationary part of the motor, while rotate in the rotating part of the motor. The stator consists of a group of individual electrical magnetic arrangement in such a way then from a hollow cylinder, which one pole of each magnetic facing toward the center of the group. The induced electromotive force is determined by the rate at which the number of flux and length charge. The greater the angular velocity v, the coil will cut the line of flux in a faster rate as more induced EMF would he would be produced. Suppose the coil is rotating with angular velocity. At any instant, the turn in the coil, the flux through the coil of area B. The rotor, the rotor obviously is located inside the stator and is mounted on the motor shaft. The objective of these motor components is to make the rotor rotates, which in turn will rotate the motor shaft. It also consisted of a group of electromagnetic arrangements around a cylinder, with the pole facing toward the stator pole. When the stator windings are connected to AC supplying flux, they produce in the air gap. The flux rotates at the fixed speed called synchronous speeds. The rotating flux inside voltage in the state the rotor winding. If the rotor circuit is closed, the current flow through the rotor winding and react with the rotating flux and the torque is produced. In a steady state, the rotor rotates at speed very close to synchronous speeds. Eddy current in iron cores or motor can cause revolve some energy losses. These are usually minimized by constructing the core out of thin, electrically insulated sheets of iron. The rotors consist of coil wound in a limited iron armature mounted on an axle. Motors are used in a wide range of applications, such as fan, power, tools, applicants, electric vehicles, hybrid cars, etc. Back EMF. When the coil of electric motor rotates in a magnetic field by applying outward a battery of potential ripples V, an induced EMF is produced. This induced EMF is made in such a direction as to oppose then V. The battery, which is known as back EMF, the magnitude of the back or counter EMF is proportional to the production of the flux of the speed. The value of back EMF is always less than the applied voltage. Here is difference between these two potentials. It is the difference between these two quantities which actually drives current through the resistance of the alternative current. Thus we have where Ra is resistant to the armature current. La is the current, E is the back EMF and V is the applied voltage. The generator outputs of the motor is difference between the supply voltage and the back EMF. An AC motor has an internal resistance of 4 theta. When powered by a 50 Hz AC supply of peak voltage 120 volt, stop on 7 minutes, draw a week, full 7 minutes, 7.01 or 02. What is the peak back EMF? Peak power delivered to the motor by the AC supply. What is the peak rates of energy loosened as heart in the motor? Where Ra resistant to the armature currents. L is the current of the back. Voltage applied is the V.